Hey and welcome back to a new video. In the past we often tested and reviewed obscure cooling products, and today we're going to look at the Ultra ChillTec. This CPU cooler is from 2007. That makes it 18 years old, and this specific unit is still new and sealed, so that will be interesting to see what we can find inside the box. And the tech in the name implies what kind of technology was used, a TEC. And we often had items with this kind of technology in the past, and it was never great or efficient. So it will be interesting to see if this item will change my mind on the topic. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comms included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. I would usually start this kind of video with some kind of comparison value with a recent air cooler on either AM5 or 1851, but the thing is, with this unit from 2007, I have no clue how this was mounted and how we can adapt the mounting to a more recent platform, because obviously 2007 AM5 or 1851 did not exist. So we will have to find a way to kind of fit this onto a recent platform. That's why we will first just fully unpack this, check all the things that were included, and see then if we can mount it on a recent platform and how. First look on the original packaging that also shows how the CPU cooler is supposed to look like. We can also see the 4 heat pipes on the side that are being detailed here on the list, with a copper base, might even be nickel plated. Originally it was supported for AM2, 754, 939 and 940, which was the same, and then 775 for Intel socket. It also comes with a control unit included that is controlling the TEC apparently, with some temperature sensors and also for speed control of the fan. I guess this is the control unit. And just to remind you, back in those days, it was just common that you would have those 3.5 inch or 5.25 inch base for the front inside your case. So it was kind of common that you could add any kind of control unit in the front of your case. It's one of those charts again that probably nobody checked, or I'm not sure how this mistake could happen. Like, I guess the left side should be the Intel Pentium 4 CPU and the right side the K8 Athon 64. But the thing is, if you check the green bar, that is the ChillTec CPU cooler. And I think they missed replacing the CPU model name with whatever cooler they used for testing it against. So yeah, that just doesn't make any sense. Some additional specs on the backside, which is interesting, especially looking at the TEC and its capacity. So we see it's a 40 by 40 millimeter standard TEC using 12 volt DC. And here we see 100% loaded or loading 50 watts. And on the bottom is also saying 12 volt and 5 amps, which is like 60 watts. But that could be for the entire like control unit. But it also already indicates that this kind of TEC will not be able to handle, let's say, a 9950X 3D. It's always cool to see this after such a long time. And I guess we can now go ahead and register our product to get lifetime warranty support. This is obviously funny considering that the domain doesn't exist anymore, and even if you use archive.org, then you will figure out that even after 2010, nothing happened anymore on the website of this brand, which is usually not a good sign in terms of the product. Or like, it could either indicate that nobody knew the product at the time, or that it was maybe not that great. But I have to highlight that this cooler looked much better than I expected. And considering that this is from 2007, the design is actually quite nice. Like, we have this heat pipe based cooler with all the fins, and the fins are nicely covered underneath those 3 CNC milled anodized aluminum sheets. And for the time, I think that was a crazy design. If this was maybe a 120 millimeter fan, I think even design-wise, this would definitely work out today. Now if we flip it to the side, we can see more of how the cooler was built. Also that it features the 4 heat pipes, 4 6mm heat pipes in a very interesting design choice. So we have this sandwich on the bottom right here, And in between, where you can see this white stuff, that's the TEC. And we have two heat pipes cooling basically the hot side of the TEC, so that's the top side right here. And two heat pipes going to the bottom piece of the heatsink, and these are going to the left portion. So this is a split up heatsink. You can see there's a cut in between. So these aluminum fins, they're not connected, which is very important. So you have two heat pipes going here and two heat pipes going there from the cold plate that's directly touching the CPU. It's always quite interesting to see the kind of design choice, and it also kind of indicates how the people were thinking about how the TEC works or is intended to work. For example, here with this like sandwich layout, the person probably thought, okay, I have my, I don't know, Pentium 4, and the majority of the heat will be dissipated through the first two heat pipes through the copper base, and then additionally we cool with the TEC that's sitting on top, which is not quite how this actually works or works best. The best approach would be to have a high capacity TEC and pump all the heat through it. So if you have a 40 watt CPU, you would need at least 80 watts or like 120 watts TEC to just get this to work to some degree. But a 40 watt or like 50 watt TEC and then like using this to help the cooling usually doesn't really work. Looking at the connectors, I think we will need some adapters. This should be for the fan, not only for just powering the fan, but also for, it's not RGB, but just B, I guess, some blue LEDs inside. A ton of accessories included different backplates for different sockets like AMD, and Intel, some additional like insulation sheets, the cables I was talking about, connecting the control unit, then connecting this to the heatsink itself, and a bunch of other like metal plates that will be needed for mounting. And I hope that I can adapt one of these for just mounting this on a recent platform. At least AM2 kind of is similar to AM5 in a rectangle shape. We'll add these to the cooler and then just measure and see how close it is. If I just place this AIO mounting frame on top, I just realized that AM2 and AM4 is the same distance for just the mounting holes. And AM5 is not much different, so just same as I did on this one, modifying, adding those extra holes. I probably can just add the extra holes next to it and it will be easy. Added 4 additional holes. That might already do the trick. And with this, the decision is also made which platform we're taking. Obviously, AM5, I picked the 7600X 3D to give the CPU cooler at least some kind of a chance to compete with a different air cooler, because if we pick something with too high TDP, then it just absolutely wouldn't work. To keep the comparison at least somewhat fair, I picked a cooler that is kind of closer to it. So it's a dual tower Noctua NHD9 something, so with a 92mm fan and also 2 stacks of aluminum fins. So I thought this might be at least somewhat similar. And we'll test this setup in 2 different scenarios. So one will be Cinebench R23 for high workload, and then the second will just be a gaming scenario. Even for the Noctua cooler, that's not super easy. We see about 85 degrees Celsius, CPU pulling about 77 watts, and the clock was between 4550 and 4625 megahertz, resulting in 12,400 points. And to keep this a bit simpler, I just kept the fan speed at 100%. After 15 minutes in the gaming scenario, we can see a peak temperature of 76 degrees Celsius, while the CPU stays most of the time in the lower to mid 60s. Power consumption is about 58 watts, and the clock is roughly the same as in Cinebench, about 4.6 gigahertz. And with this, we can start to mount the ChillTec. Cold plate looks alright. It's always some kind of a problem if there's such a film or like sheet on it with some glue. Then some residues always get stuck to the cold plate, so we'll have to clean that off real quick. Thermal paste is already applied, and I just noticed that the orientation of how this cooler is mounted is quite odd. Like nowadays, any air cooler would have the air directed towards the rear fan, but on this one, as you can see, this wouldn't work, like with the mounting plate. So either like this direction or the other one. And especially with the 50 series, with the like blow-through design, it would intake definitely the hot air from the card like that, but I think there's basically no other choice. I will definitely mount it the other way. I think this way it's just better to mount it, doesn't collide with the GPU, and I can easily access the cables. And it fit perfectly with the Noctua screws and the adjusted mounting holes. Now we only have to connect the controller, but I'm not quite sure if it's an actual controller or if we can even adjust anything, because the buttons only read color and switching between degrees Celsius and Fahrenheit. Also in the back there's only the cable connection, so we have the TEC on the right and then the connection for the fan. Well, let's see what happens. Interesting, on the controller we have a counter for how many hours it has been powered on. We have temperature signal and a guy that is apparently doing something. Here we can indeed just switch between the two metrics, and then here, cycling through colors. There is some sort of fan control, at least it's constantly ramping up and down, which is not that great, but I mean it's doing something. This behavior can also be seen in hardware info. We can see it constantly goes between 2000 and like 5000 RPM. Not exactly sure why it's doing that. We'll see if it also happens under load. Idle temperature also looks okay-ish. We see between 30 and 40 watts right now. I think it's doing like updates in the background. And with this, it's about 30 to 40 degrees. So that's okay. I will just wait for Steam to complete the PUBG update. That's very important. And after that, we will first do the gaming scenario test to see what kind of temperature we can see there. Previously, we saw between 60 and like 65 degrees Celsius in a remnant gaming scenario. I think it's also okay with this setup because the CPU block is almost in the center of the 5080, so the 5080 can easily blow through left and right with the hot air and thus maybe not influence or impact the CPU block that badly. Also, there's indeed nothing we can adjust on the controller. The only thing you can do is just watch the small guy digging his hole deeper. The result is much better than I expected. CPU package power is still at about 57-58 watts, so same scenario as before, but the temperature is also better. Obviously, the fan is a bit louder. I think it's spinning much higher than the Noctua fan, so it's somewhat of an unfair comparison, yet the temperature looks really good, about 50 degrees Celsius on the cores, and up here we see about 58. Of course, the high RPM fan is giving this cooler an unfair advantage, yet I did not expect it to be that much better. But let's see about Cinebench. As you can see, the scenario is still the same, about the same power draw, and at least in the beginning, this doesn't look bad at all. Cinebench is almost over and the temperature was better than with the Noctua fan. Also, performance is exactly on the same level. We have to rerun it to check the frequency under load, but I think 12,400 just indicates that the frequency was on about the same level. Now, second run, we can see that the clock is about the same. It could be even 25 to maybe 50 megahertz higher, but that won't make a big difference. But at least it's the same scenario. Honestly, this just surprised me because most of the time this type of cooler just doesn't perform well once you have like full CPU load with high temperature and then also the TEC that is pumping energy into the system. But with this, it was surprisingly good. Now the question for me is, does the TEC actually do anything? Like, does it help? Or is it worse because of the additional heat that is being pumped into the system? I think I will just try to unplug it while it's running Cinebench and see what happens. The question is also if there is some sort of safety feature implemented if the TEC is no longer working, but I don't think so. Unplugged the TEC, everything is still running. Also here it looks all still the same. I think the only thing I noticed is that the temperature maybe increased a little bit, but I have no clue where the temperature sensor actually sits. At least my initial impression is that the TEC definitely helped. So I think just after this quick Cinebench run, we see an increase in temperature versus without the TEC. We definitely did not see 84 or 85 with the active TEC, so it definitely helped. There's one cool thing I just noticed while attaching the current clamp. You see high current, so that's about 60 watts going through the 12 volt of the Molex. Now it's like no current, now it's high current. And that is kind of like paired or like attached to the fan speed. Whenever there is like low current, like right now, the fan is low speed, high current, high fan speed. So there is some sort of active control, which seems to be like switching or turning off and on the TEC which I think is a great thing in theory, but they maybe failed with the parameters, because I think if it was like idle, like right now, nothing is happening, it would be cool if the TEC was switched off and the fan would run at a low speed. I think that's the idea behind it, but I think they just failed setting the right settings for the temperature where it's supposed to be switched on or off, because like this, even in idle, it's currently or constantly ramping up and down. The Ultra ChillTec was definitely ahead of its time, especially if you think back to 2007. This would have performed quite well, because also, like going back there, the CPUs didn't consume as much power as what we have now with AM5, the big CPUs, or even 1851. And keeping that in mind, I think it wouldn't have been bad. And if you would have added additional features, such as more control over the TEC and like fan speed, this would have been a banger, I think. But even all of this, like neglecting the missing control over the TEC and the missing fan control, this is not that bad. It honestly surprised me, because from all the testing I did so far with multiple TEC coolers, most of the time they just fully disappointed, and this one actually worked. Hope you enjoyed this video. See you next time. Bye bye.